Hello and welcome to my YouTube channel. This is Raman Online Mathematics. If you know you have not subscribed, please subscribe, share to your colleagues. Make sure that you like the video as you watch. Thank you very much. Now we are going to look at the computation of Fourier series. But the computation of Fourier series is very simple. Already we have discussed about the Fourier series, the formula, where we said that f at x is giving us a naught plus summation of n as n equals 1 to infinity an cos nx pi over l plus bn sine nx pi over l. This is what we have, right? I think this one was over 2. Is that okay? The a naught was over what? 2. Good. Okay, so this is what we have, the formula we have for the Fourier series, okay? Now I realize that the an consists of the cos, the bn consists of what? Sine. So what happened here is that for the a naught, if you want to integrate the a naught, it's always giving us 1 over l integral of negative l to l f at x dx. So this is when you want to integrate a naught. You want to integrate an, giving us 1 over l integral of negative l to l. So this is an. The function f at x cos n x pi over m, right? Dx. This one you want to integrate the an. This is nothing difficult, okay? The f at x is the function that will be given to you, but the an is multiplying the cos this, so that is why I'm bringing the cos nx pi over l. So we have bn, which will also be the same 1 over l f integral of negative l to l f at x. So we go this way, sine nx pi over l dx. So this is the formula we are going to use so far. So when you want to find an, you only use this. Bn, you use this. A naught, you use it. After that, you go and substitute it there, and you are good to go. Is that okay? Very good. So now let's look at an example. All right, now let's look at our first example. Compute the Fourier series of f at x equals x. So f at x is what? X. On the interval negative pi pi. Write the first 4 terms of the series. So for you to be able to do that, what you do here is that you know the formula given is what? A naught over 2 plus summation as n goes to 1 or n equals to 1 to what? Infinity a naught cos n pi x over l, right? Plus bn sine n pi x over l. So this is what you have. Now, having to have this formula, you are going to find a naught, an, bn. So first, let's look for the a naught. My a naught is going to be 1 over l, the integral of negative l to l, f at what? X dx, right? So here is negative l and here is l. So that's for the limit. So this will be 1 over pi, the integral of negative pi to pi, f at x is given in the question as x. So here will be what? X dx. Now let's look at something here. What function is x? It is odd function or even. It is odd, right? And we said that anytime you integrate odd function with a symmetric limit like this, what do you get? You get what? 0. So that's why I said that the properties that I taught you in the previous video is very, very important. Understand them. When you are integrating limits, a function, and that function is odd, the this thing, how do you call it? The integral of it becomes 0. That thing only happens if this and that are symmetric. That is negative pi or negative 2, 2. Okay. Now, once that one is 0, let's also look at an, which is giving us 1 over pi, right? I'm going straight. The integral of negative pi to pi. The function is what? X. You know an is cos. Now here is supposed to be n pi x over L, but here L is what? Pi dx. But remember, this pi will cancel this pi, leaving an equals 1 over pi integral of negative pi to pi x cos nx dx. Now this is x cos nx. So if you are to integrate this, you need to use what? Integration by parts to do this. But remember that if you want to use the integration by parts, check the function. If the function is odd, then it means that the integration of this will also be 0. So the x is odd, cos nx is even, because you said that cos is even. So if cos is even and x is odd, odd times even is still odd. So anytime you integrate odd function in the form like this, you get what? 0. Good. Now I left with the other one, which is the bn. So my bn here, this is how the bn is going to look like. 1 over pi integral of negative pi to pi x sine nx dx. You know why I'm not bringing the pi again? Because pi over pi will be 1. So we have only nx. I did that here. Good. So now let's look at this one. If this one will give us 0. This is x, which is odd. Sine 2 is odd. Odd times odd is even. And since it is even, it is not what? The integration of it is not what? 0. So here you have to integrate. This integration by parts. So now if you have something and it is even like this, for the even function, when you integrate, it won't give you 0. So only the odd that gives 0. So you have something like this. What you do is that you use integration by parts. But I'm not going to use the formula. I'm going to use a table. So the table, we have u, you have v. What you do here is that the v side is what we are going to integrate, and the u side is what you are going to differentiate. So you look for these two functions. The one that when you differentiate, it will terminate to 0. So x will definitely terminate to 0. For sine x, no matter what you differentiate it, it won't give you what? 0. So you put that one at the integration side. Now if you differentiate x, it will give you 1. Differentiate 1, it will give you 0. If you integrate sine x, it gives you negative 1 over n cos nx. If you are confused about where the n is coming from and the negative, when you integrate sine, it gives you negative cos. If you differentiate cos, sine gives you positive cos, but when you integrate, it gives you negative cos. Also, when you are integrating it, this is a composite function. So a function in a function, right? So the sine x, when you integrate, that gives you the cos. But the inside one here, we differentiate. Okay, when you differentiate nx with respect to x, that will give you n, but it's over. That's why you see it like this. Now let's integrate cos. That gives you positive sine. So here will give 1 over. Remember, when I do this, there will be over n again. That n multiplied this will give you n squared. And cos, if you integrate it, it gives you positive sine. So the negatives here will still maintain nx. Okay. Good. So now for the table side, what you do here is that this x here will match with this, and this will match with that. Is that okay? So you have plus, minus. Good. So this is what we are going to what? Use. So I'm going to use this one. This is what we are doing, okay? So my bn, let me use this one straight. So 1 over pi, integral of negative pi to pi, x sine nx dx, right? So this one will be equals to, that's what I've integrated here. So it will be x times this, which will give you positive multiply negative. That gives you negative x over n cos nx, okay? Then 1 times this one, negative times negative, that gives you positive 1 over n squared sine nx. Is that all right? Good. So this is what we have. Now after this one, we have to substitute negative pi towards pi. So that's what you are going to do here. So let's start. I'm going to put the pi here first. So I'm going to have, wherever I see x, I'm putting pi there. So I'm going to have negative pi over n cos n pi. Is that all right? Plus 1 over n squared sine n pi. That is for the positive side. Minus bracket open. Remember, this is what? Negative, right? I'm going to substitute negative here. Already there's minus there. Now if I put negative in here, the negative will cancel this negative, making it what? Positive. So I'm going to have positive pi over n cos n pi. Remember, if I put negative pi here, if I put negative pi here, cos it is cos, the negative will vanish, right? Now if I put negative pi here, the negative will come out because this is odd function, this is even function. So here we can minus 1 over n squared sine n pi. Let's close the bracket. So this is what we have. Now can I clean this side? Okay. This here, I want to show you something. See, this is n pi. Now let's test when n is 1. When n is 1, you get cos 180, which is negative 1, right? When n is 2, we get cos 270, which is 1. So you see here, when n is 1, you get 1 or negative 1. When n is 2, you get 1 or negative 1. So it will be rotating like that, either negative 1 or positive 1, negative 1 or positive 1, negative 1 or positive 1. So what do you do to make it one number? But here, when you put n to be 1, sine, how do you call it? 180 is 0. When n is 2, sine 360 is 0. Sine, whatever you get, it will be 0, 0, 0. So for this side, it's proving that since n is any number, when you put it there, you get 0. You can say that sine n pi is what? 0. So here you say that sine n pi is 0. But you're saying that cos n pi is not 0. What I'm saying here is that if I put, let me do something here for you. You know, this place is what? This is y, right? So here will be 0, 1. Here will be 1, 0. Here will be 0, negative 1. and here will be -1, 0, right? So this is what we have. Now remember, cos is for x side and the sine is for what? Y side, right? So if we have this, means that here cos 90 is 0, cos 180 or 270 is -1, cos 180 here is 0, cos 360, depending however you are saying it, is what? 1. So what I'm saying is that for the cos, it rotates. It's either 1 or -1, 1 or -1. So here, for you to be able to cater for that, wherever you see cos n pi, then now if you look at this one, cos n pi, this I will do it to be -1 to the power n. This is what I want you to know. So wherever you see this, why am I saying this? Because everything you are doing, you either get 1, whatever n value you put here, if you put 1 here, or 2 or 3, either get 1 or -1. So if I write it this way, means that -1 to the power n, when n is 1, you get -1. Is that okay? It means cos 180 is -1. You understand what I'm saying? When n is 2, you get +1. It means cos 360 is 1. So what we are saying here is that this n here will help us to get our answers. Wherever you see cos n pi is -1, I will not repeat it again as I start solving the question. Okay. So like this, if that is the case, means that the whole of this place will go to 0. The whole of this place will go to 0. If the whole of that two places goes to 0, then the two, what you have here is this one and that. Is that okay? So, and cos n pi is now -1 to the power n. Cos n pi is -1 to the power n. So here you are going to have our bn equals -pi/n, bracket of -1 to the power n, because you say cos n pi is -1 to the power n, minus -pi/n 1 to the power n, minus this. Is that okay? Good. So if you look at this one, this and this, they are the same, so I can write it as -2 pi over n, -1 to the power n, right? Now look what is happening here. Let's do some more algebra. I can write this one as 2 pi multiplied by -1 multiplied by -1 to the power n, all divided by n. Do you agree? Why am I saying this? You see, this -1 here is the -1 here. Is that okay? If I multiply this -1 to this, I'll get this one back. Then this -1 to the power n is what is here. Now remember your indices. If the bases are the same, we add the powers. Means that my bn can be written as 2 pi. Then I write one of the base, right? -1. I add the power. That gives me n plus 1. And this one is divided by what? N. So this becomes our bn. Is that okay? Good. So you go back to the formula. Then you go and substitute our a naught, an, and the bn. But remember, a naught is 0, so this place will go to 0. An is also 0. This place goes to 0, leaving only this. So my f at x equals x, which is approximately the summation of n equals 1 to infinity. This is 0, this is 0, so let me take this. The bn I had 2 pi -1 to the power n plus 1, all divided by what? N. All divided by n, multiplied by, that is the bn alone, and it's multiplied by sine n pi x over what? L. But here my L is pi. So this one will cancel this. So there's no need to write everything. So nx. Okay, so after getting this one, the question said write the first 4 terms of the series. So when n is 1, what do you get? So when n is 1, it means that wherever I see this, I put 1 here, I will put 1 here. If I put 1 here, it will be negative 1 to the power 2. 1 plus 1 is 2. And negative 1 to the power 2 is positive 1. And n is also 1 here, right? So it will be 2 pi over 1 sine x. So when n is 1, we have sine. So we have 2 sine x, right? Now n is 2. When n is 2, what do you get? You put 2 here, that will be 3. Negative 1 to the power 3 will be negative 1 still. If I put 2 here, the 2 will cancel these 2, leaving negative pi, right? And here will be 2x. So when this, we have negative sine x. Sorry, negative sine, not negative pi. Oh, there's still pi here. There wouldn't be any pi though. I've made a mistake somewhere. Because remember, the formula is supposed to be 1 over pi integral of negative pi to pi, right? So when I solve it, I had pi here. So there must be pi here. And this pi will cancel this, please. So there won't be any pi here. So here will just be 2. I forget to bring that. Thank you. They have n equals 3. So when n is equals to 3, if I put 3 here, will be positive 4, right? And this, it makes this one positive 1. If I put 3 here, 2 over 3 here. So you have 2 over 3 sine. This side will be 2x sine 3x. And the last one, when n is 4, you have 2. If I put 4 here, will be 5. So that makes this side negative, right? And also 4 here to be 2 over 4. That will give you 1 over 2 sine 4x. Is that okay? So the first 4 series of this is going to be 2 sine x minus sine 2x plus 2 over 3 sine 3x minus 1 over 2 sine 4x. Is that okay? And remember, the x is odd function. So if you are getting only odds, no problem with that. So this is what we get for the first 4 things. Let's move